All right, good morning. My name is Mark Grimes. I am a field technical consultant out of the Columbus, Ohio district. I cover a territory in Kentucky, Ohio, and Indiana. And today we are going to go over the iComfort S30 and E30 product installation. We're going to look at hardware and wiring and hookup, and to make sure we can get that get that correct, because this is where it starts. Okay, if we don't get this correct, we'll have a product that really won't work for us very well. So those are the things we're going to cover today. Okay, we always start out with our core values, and I'm sure we all share these: integrity, respect, and excellence. And like I said, I know that we all share these core values, and Lennox puts a lot of value in these. Okay, so S30, wiring and hardware. We are going to look at the 3.0 display and 3.0 Smart Hub. These have screw lug terminals, which I'll show you here in just a minute what those are. They have been upgraded to that, makes it a much better product, much easier to wire and install. So here we have the display, and we have our sub base here, which has 4 screw lug terminals for your wiring. And we have the Smart Hub, which also has screw lugs for wiring. Makes it a much easier way to wire up and install. Here is the 3.0 display wall base, okay, the sub base, and this is what the display will snap onto after we get it wired up. And as you notice here, we have 4 lug terminals here to put your to hook up your wiring. The far left one here is your positive, and the far right is your negative for your 12-volt DC voltage. The 2 middle ones are your A and B, which is your communication bus. Okay. As you can see, the back of the display has 4 pins that will snap right into those lug connections to make the electrical connection for the display. Your wiring connections on the Smart Hub are as follows here, as you can see in the pictures. For the display, the sub base for the display, you have your plus and minus, which is your 12-volt DC power supply, and your A and B for your communication bus to the sub base. On the right side, we have our power and our communication bus down to the indoor unit. We have R and C, which are your 12 volt, or I'm sorry, 24 volt AC power supply. And we have our I plus and our I minus for our communication bus. We also have accessory terminals here for different things such as humidifier, whatever, and our communicating um, dehumidifiers, things like that. Okay, is what the accessory terminals would be for. Okay, so starting over here with our wiring to our sub base for our display. Like I said, we have our plus and we have our minus. That is our 12-volt DC circuit. And our A and B are our communication bus. This is arranged a little different from the 2.0 Smart Hub, as those terminals were lined up like down here. We had plus, minus, and A and B. So as long as you're looking at your nomenclature, you should have no issue wiring it up. So plus and minus is your 12-volt DC circuit. A and B is your communication bus. Okay, so this is very important here. We are recommending that we run our communication wiring in two conductor shielded wire. Okay, the I plus, I minus, all the way through outdoor unit to the indoor unit, from the indoor unit to the smart hub, and from the smart hub up to the sub base on the wall. The communication bus would be highly recommended to run twisted pair shielded stranded wire. The power supply, all right, which is your plus and minus, which is 12 volts on this side, uh, and from the smart hub to the indoor unit, R and C, and then from R and C from the indoor unit, okay, to the outdoor unit. That is all your power supply, and that is recommended to run in two conductor regular 18-2 thermostat wire. So two separate cables of two conductor wire is recommended here. Okay, this wiring diagram is in the installation instruction, and if you follow this, it will greatly reduce the problem of communication errors. Okay, so following this wiring in the installation instruction will certainly help cut down on those things. This is also in the installation instruction by the wiring diagram, kind of showing you which wire to use for which terminals. R and C is your 24 volt power supply. You can run regular 18 gauge two conductor wire unshielded for that. Your I plus, I minus, we are recommending that you run shielded twisted pair stranded wire. Okay. For the accessories, you can use regular 18 gauge two conductor wire. And for the communication bus up to the display subbase, also shielded twisted pair. Okay, so all the way through on the communication bus, uh, shielded twisted pair wire. That is what's recommended. Okay, here, just showing you a visual here of the wiring. Okay, this is your sub base, okay, up on the wall. And this is the smart hub. So we're showing two separate cables, okay, one for the 12 volt DC, that would be your regular thermostat wire, and then one for your communication bus, and that would be your shielded twisted pair wire. From the smart hub to the indoor unit, okay, on the communication bus, shielded wire, and I couldn't put them in one jacket showing one cable, but the two outer wires here, R and C, are one cable, and that could be regular thermostat wire. And the same going from the indoor unit to the outdoor unit. All right, we have shielded twisted pair wire for the communication bus, I plus, I minus, and we have one 18 gauge two conductor cable for R and C. Regular thermostat wire where you have multi-conductors in one cable is not recommended. However, I do know that that is used quite a bit out in the field, especially when you are replacing a system that already has thermostat wire there. Sometimes you do have multi-conductor wire. If you choose to use that, this is how we want you to do it. Okay. So any unused conductors, putting under a wire nut and draining those back to common at the indoor board. Okay. So wire nut here with a wire going up to common, and the same for any other unused conductors, and bringing those all the way back to common at the indoor board. However, now we do not uh, recommend this way. If you can change the wiring, it is better to do so to cut down on communication errors. Okay. So if you choose to do it this way, there is ways to wire that to help cut down on communication errors. But if you can change the wire to two conductor cables, that would be better. This slide is showing how to check regular thermostat wire to see if we have voltage bleed over between conductors. Okay, so we disconnect all conductors on both ends with the exception of the R wire at the indoor board. Okay, all wires are disconnected except for the R wire at the indoor board. And then we take our voltmeter, set it to volts, and we check each disconnected conductor to common to see what kind of voltage we may have bleeding over from the R wire. And we are looking for really less than 3/10 of a volt. Okay, so 0.3 volts. Okay, we're looking for less than that. If we have greater than 0.3 volts, then we are crossing voltage over to other conductors, and that could give us communication errors because that is being inducted into the communication bus. And we do the same thing for the cable going out to the outdoor unit. Okay, so again, if this is regular multi-conductor thermostat wire, okay, we can check it by disconnecting all wires with the exception of the one going to the indoor board. Okay, we do disconnect it at the outdoor unit, but the only connection is here at the indoor board at R. And then we take our voltmeter and we check for voltage on these disconnected wires to common to see what kind of voltage we may have bleeding over from the R wire. And we are looking for less than 3/10 of a volt. If we have more than that, the wire is considered bad and needs to be replaced. And hopefully we can replace it with two conductor cables. Okay, this slide here is a little busy. Is a lot of wires here, but this is with all accessories. Okay, and we have our smart hub. Okay, we have our outdoor unit, which those will be the main ones. You could have a Pure Air S. Okay, and we could have um, a zoning control as well. Okay, so all of these could be in here, and this is showing how to run two conductor cables. One is shielded twisted pair. This would be the brown one, and the regular 24 volt 18 gauge two conductor would be the blue. Okay, so this is kind of just laying out all the components that could be in the circuit and showing how to wire them. Okay, a little busy, but I think you get the idea. This is highly recommended to wire this way. Okay, so we do have a couple of service and application notes that kind of help guide you in troubleshooting, electrically, troubleshooting the circuit. The first one here is the number on it is ACC-17-01. That could be downloaded from Linux Pros. Um, and we have another one here. The number on it is 100009. It also can be downloaded from Linux Pros, and this is a service and application note on the recommendation for using shielded cable for the communication wiring. Okay, and it's a very good service and application note. I would highly recommend you download those and have those with you. Okay, when installing or troubleshooting S30 or E30 thermostats. Okay, if you use iHarmony, okay, zoning, just make sure that all wiring pulls to the indoor unit Okay, your zoning control goes to your indoor unit. Your thermostat or smart hub goes to the indoor unit. Okay, and then from the indoor unit to the outdoor unit. That is not shown on this diagram, but that is how we would wire that. Okay, so if we have a float switch, okay, so we had a condensate switch that we are going to wire into this circuit. Okay, if you have a non-communicating outdoor unit, we would prefer you to wire this float switch. And if you have a free stat, you can also wire it in here like this. Okay, but typically you're just going to have a safety float switch here. We wire it through an isolation relay. All right, that is highly recommended. Do not just put the float switch in the middle of the wiring, wiring it in series. Use uh, a isolation relay. That is much better. Okay, so if you have both communicating, both indoor and outdoor units that are communicating, you would wire your float switch like this diagram. Okay, now all this wiring is in the installation instruction for the S30. Okay, so you would wire it between R and DS on the conventional terminal strip of the indoor board, and you would clip the jumper from R to DS. Okay, there's a jumper right near the terminal strip, and you would clip that R to DS jumper and wire your float switch in like this. So if both your indoor and outdoor unit are communicating, if the float switch would open, that would shut down your outdoor unit. Okay. You can also wire it like this, okay, with an isolation relay. Never put a float switch, okay, just in line, okay, either wire it like this if it's fully communicating, or if you have a non-communicating outdoor. Okay, so that concludes the S30. So we're going to go ahead and look at the E30 here, since it is similar and has similar components, have a couple of redundant components. And so we're just going to look at the E30 thermostat, and we'll look at some of its wiring. Okay, so the subbase and the display are identical parts to the S30. So they are no different. So they can be interchangeable from E30 to S30. The only thing different is your Smart Hub. Okay, the Smart Hub is different with an E30 since we are going to wire conventionally to the equipment. With the E30, we do not communicate directly with the equipment like we do with the S30. So we have to have a smart hub that puts out um, conventional type signals, 24-volt AC signals to the equipment. Since the E30 does not communicate directly with the equipment, you do have to set it up. Okay, you do have to configure the type of equipment that you have. Okay, so it's pretty easy to do. This excerpt here is this little um, two jumpers up here. It's a little small, so I had to blow it up and I put it here. Okay. So the E30 Smart Hub comes with the jumper defaulted to IFC. So from the factory, it will be on IFC, which stands for Integrated Furnace Control. Okay, it will be there. If you have a gas furnace involved with your system, okay, it will be on IFC. Even if you have a heat pump for dual fuel operation, okay, so if you have a hybrid system with a heat pump and a gas furnace, okay, we call that dual fuel, okay, it will still be on IFC. Okay, we never put it on heat pump, okay, HP. We never put it there. That is for some kind of future use. But for the moment, for now, we do not use HP. Even if you have a heat pump with a gas furnace, you will put it on IFC. If you have an air handler, such as a CBA 25 or a CBA 27 or a CBA 38, you will put it on AHC, which will be air handler control. That's what it stands for, air handler control. So if you make it easy, if you have a gas furnace, it's IFC. If there's an air handler, AHC, regardless of what the outdoor unit is. The heat stages, if you have a gas furnace, if it's a single stage gas furnace, you're going to set this to 1. If it's a 2-stage gas furnace, you're going to set it to 2. If it's an air handler with electric heat, you're going to set it to 1. Okay, set it to 1. If the air handler does not have any heat, you will put it to 0. Okay. Okay, so with the new E30 Smart Hub, what connects to the um, display subbase is the same as the S30. Okay, you have a plus, you have a minus, that is 12 volts DC. A and B is a communicating circuit up to the display, okay, subbase. And we recommend 2 cables if you can do that. All right, that cable is that is going to be the hardest one to pull. If you can't change it, okay, I understand. I don't have that much problem out of this pull because the power supply is 12 volts DC. It's the 24 volt AC circuits that are the problem with the S30. Okay, but you don't have that issue with the E30 since we have regular outputs, 24 volt AC outputs to the equipment. Okay, so with that, the sub base will wire the same, and you have your 12 volt plus and minus. That's DC circuit. And then you have your A and B. It's the same as the S30. Okay, so with the E30, we have your wireless. You can set it up with your router and have internet connection and so forth. It has 3 languages, English, French, and Spanish, just like the S30. Okay. And it allows most conventional 24 volt AC furnaces and air handlers. All right. So you can use the E30 with pretty much any system. Okay. It does have humidification. We have dew point control if you want to set that up. Dehumidification, we have that. It can be all set up for dehumidification. Equipment maintenance reminders such as filter or humidifier pad. If you want to set up for the homeowner to remind them to change those, we have that in there. Of course, heat and cool modes, and it permits all of this: heating, cooling, humidification, dehumidification, okay, automatically. We also, if they are signed up, uh, with their account and so forth, they will get performance reports via email. Okay. Okay. So the differences between the E30 and the S30. All right. Here's what the differences are. Okay, the iComfort E30 is universal and it's designed to work with just about any equipment out there. Okay, any system, any residential split system, it will work with. The S30, of course, has to work with our communicating indoor and outdoor equipment. Okay, it is non-communicating versus the iComfort S30, which is communicating. And we're talking about communicating directly with the equipment. So the S30 does that. It will communicate directly with the equipment. The E30 does not. Okay, the items the iComfort E30 does not have versus the S30. We have these 5 things here. Okay, so precision comfort. That is a setting with the S30 because it communicates directly with the equipment and can communicate those things and operate the equipment to achieve precision comfort. Advanced alerts, since the E30 does not communicate directly with the equipment, we do not get any alerts. Okay, automatic setup. With the S30, it communicates with the equipment, so it kind of knows what's out there. It knows the size and so forth. So it kind of sets itself up where the E30, of course, is not communicating with the equipment and cannot do that. Okay, automatic self-test. Okay, so we can do some tests. We can run heating and cooling calls through tests, but it will not do automated tests. Okay, and of course, we do not get any detailed diagnostics because the E30 is not communicating directly with the equipment. It's best not to put the smart hubs in the attics, okay, or maybe in crawl spaces, okay, where moisture and heat can be excessive. So it's better to have those in the conditioned space if you can. Here are the operating temperature ranges and so forth for the smart hub and also for humidity, okay? Of course, we have to be careful with that. So better to put it in the space if you can. Okay, the E30 Smart Hub power input is 24 volts AC. All contacts are 1 amp rated. Okay, no more than 1 amp. And of course, at 60 hertz. The Smart Hub out to the sub base, okay, for the display, that is a 12 volt DC circuit. Here are the dimensions. If you're interested in the dimensions of the Smart Hub, 11 and 3/8 tall, 7 and a quarter wide, and inch and 3/4 thick. Okay, and of course the antenna, we have one antenna, and it is 7 and a quarter inches long. And of course that is for connecting to Wi-Fi. Just a tip here about thermostat wire, where it penetrates the wall. It is a good idea to seal that hole. Okay, do not leave any open holes or cavities behind the subbase of any thermostat. That is a good practice. And here is a drawing of the E30 Smart Hub. Here is where you set your unit type. Okay, again, if a furnace, a gas furnace is involved, it's IFC, which that is where it comes to you from the factory. If you have an air handler, CBA 25, 27, or 38, then it will be on AHC, regardless of what the outdoor unit is. Heat stages, again, gas furnace, if it's single stage, it'll be on 1. If it's a 2-stage gas furnace, it'll be on 2. If it's an air handler with electric heat, it'll be on 1. If it's no electric heat, it'll be on 0. We can hook up an outdoor sensor or a discharge air sensor, and this is where that would hook up. Okay. The outdoor sensor, and it's not in here, but the catalog number is an X as in X-ray 2658. That would be your outdoor sensor. Here are your conventional hookups. Okay, this is where your conventional out to the equipment would hook up along here. We'll have a slide here in a moment that will show those. Okay, and we have our status LED and we have our commissioning LED. Okay, which that will be blue. Okay, unless we're commissioning, and then it would be green. Our status LED, hopefully we will eventually make it green, okay? But it could be multi-colors depending on if there are error codes or if we're not hooked to the internet or something like that. It can be it can be other colors. Okay, so some things to consider. Okay, the Smart Hub installed near the indoor unit, but also where we can get a good a Wi-Fi signal from the router. It can be horizontal or vertical, doesn't matter. Either way you want to do that. The antenna, of course, should be out where it can get the best signal. Don't install on the ductwork. Ductwork is metallic and it can interfere with the Wi-Fi signal. So try to not do that. Put it on the wall or maybe on a ceiling joist or something like that. And stay away from fluorescent lights or any other high voltage lines and things like that. Install it, where it's not close to those things. Okay. Okay, so here we are with our conventional terminals. Here is our nomenclature. This is in the installation instruction to tell you what they are and what they're for. Okay, and we can go down the line. W1, W2, W3 is your first, second, and third stage heat. Okay, your G is your indoor blower. Y1, Y2 is your compressor demands. Okay, Y1 first stage, Y2 second stage. DS is a dehumidification signal, and you can have extra dehumidification if you program it for that, and you can get a DS signal out to the equipment. Of course, on the equipment, like if you're, uh, you would have to clip a jumper on some equipment. So you just have to read the installation instruction for that equipment to see how it operates with a dehumidification signal. C is your 24-volt common. R is your 24-volt power, AC. And H is a humidification output. All right. So if you program your stat to for humidification, when it needs humidification, a 24-volt signal will be put out on the H terminal. The two remaining terminals are O and B. This is for your reversing valve. Linux always uses O. All right. So Linux equipment and most other manufacturers will energize their reversing valve in the cooling mode. So that would be an output on O. If you have a ream unit or any other unit that would energize in heat mode, then you would use B. Okay, but for all Linux equipment, it would be O to O on your equipment for reversing valve. This would be for heat pumps only, of course. Okay, and on the E30 Smart Hub, we have this sticker. Okay, it has all this information, everything that I've covered so far. Okay, it is on there. Kind of shows you how to wire it and so forth. Shows you how to set it up for your indoor equipment, such as your gas furnace or if it's an air handler. Shows you that. Again, a reminder: do not never put it on HP. Okay, regardless of what equipment you have. Okay, and that concludes our presentation for today. This is basic wiring and setup for the hardware and so forth. And in future presentations, we'll be covering some programming and troubleshooting and so forth. So, but this concludes this for today. Thank you for watching, and you have a great day, and I will hopefully see you soon.